Hi everyone, welcome to 202. Sorry for the slight delay start. Had to make a phone call. All right, so today is the last day before the second exam. Now we already finished covering that material a long time ago. I think recursion was the last thing, but I guess I'll do a little Q&A. Maybe we'll reserve the last half an hour or something for Q&A on the test. Maybe. Well, it's not much I can tell you about the test since I didn't make it, but I can answer questions on material that you might be stuck on. I know you're all going to ask me like what's going to be on the test, but unless I look at the questions individually and like I can't really give you much of it. I mean, it'll be the same stuff as the first test, but on the topics of the second test. So, anyways, we'll get there when we get there. For now, however, the topic is linked lists. So far, we've been looking at singly linked list, and today I want to wrap up talking about singly linked list so that we can then start talking about doubly linked list next class. And yeah, so we'll be talking about doubly linked list next class, and then the week of Thanksgiving we'll do stacks and queues, and then we'll be basically done with the material. So I still want to do it on Thanksgiving week because then we'll be done and study week can be review week. But if not, then we'll see and maybe we'll do finish talking about it on study week. But I'd rather finish it sooner than later because you have the final project, which is on stacks and queues implemented using a linked list. So, the sooner we get there, the better. All right. So I was hoping that somebody on the chat or on Discord would have figured out our issue from last time, but nobody said anything, and I really didn't look at it. So we are still in that situation where the code that we did last time doesn't work. So, maybe it doesn't work because we need to make this a 2. But no. It's just, it's weird. You see, it's only printing one linked list, even though we have 2 prints here. This should really say print 2. That might make a difference, but I think it's, if I recall, it was seg faulting. So yeah, we never figured this out. So let's kind of work it out and see where we're at, and then go from there, right? So you remember what we did last time is we did all the different inserts, and then we tried to do a combined insert that inserts everything sorted. And so that's where we try to do it, and then didn't really get us anywhere. So for that, let's just see if the uh, if it's something to do with list 1 or list 2, right? So if we run it like this, yeah, just seg fault. So I don't like how it doesn't tell me it's seg fault. Here, I opened this like 2 hours ago. So let me open it again. All right, here we go. Oh, choose language. All right, so if we try to run it now in debugger mode, get rid of the breakpoints for now. Start. We can see that it is seg faulting. I remember now yet in this line, cur data. So it is telling me that more than likely, you know what it could. I got a theory about this actually. Um, our class for the linked list, yeah, it's how simple, a lot of the times, I mean, I'm not saying this is going to fully fix it, but a lot of the times all you got to do to fix code is just take a break and step back and come back to it a little bit later. But I do see one thing that is bad here, and that is that we are checking whether head is null to find out if the list is empty or not. However, we never initialized the head pointer on the linked list class. You see, we just created, which has garbage, which means that it's probably accessing garbage for the cur, and that's why cur data is crashing. In fact, I'm like 99% sure at least this is one of the problems we have. It might not fix everything, but it'll definitely fix at least this crash, or at least get us closer to the solution. So what we need here is either to set this to null PTR. Let's terminate that. Okay. With a constructor, or just to do it directly here. So I'm just going to go ahead and do it there to save time. So now we are initializing head to null when we create a linked list class. That is just going to do tons and tons of help for us. In fact, let's just try to run it now and see what happens. All right, so we got a little further. Now we're stuck in an infinite loop. So that's not as bad. Okay, so let's run the debugger and let's take a look at that. So let's put it here and let's run it. Okay, so now let's just go line by line. So we're going to go in insert end, which we know it's okay, so we just let that run. Let's just step out of that function. All right, insert at, that's the one we want to see. So insert at, first we create the new node that we want. That's okay. Runs a constructor to create that node, sure. We are going to go ahead and assign the head to a cur pointer. That's okay. Oh wait, insert add is actually, oh wait, no, that's a different function. We already know if that's okay, I think. Yeah, that function's okay. We don't need to worry about that function. This is the one we want, insert sorted at. So step into that one. Okay, so create a new node, run the constructor for that. All right, so right now, the first time we insert something into this, it's empty. So we know that it should go in here because head should be null. So now, before it was like ignoring this, and then it was segfaulting. Now it actually sees that it's null, so it sets the head to temp. And that's it. That's all we got to do. So that's good. That is actually working as expected. Let's do A now. A should go at the beginning of the list, but the list exists already. So we're going to create the new node, sure. But now it should not go into this line. It should go into the else clause. It did. That's good as well. Good progress here. All right. So we want to insert at the beginning of the link list. So we have one item on the link list already. So we're first going to set up our cur and previous will point to the head. And now we're going to iterate here until cur hits null. So the first time, cur is pointing to the only item in the link list. So we're going to get that piece of information from here. Cur data should contain a t. Variable watch here, it's just giving us a value. It's not really going to dereference it for us. We'll see. Let's see, step into. Doesn't really dereference it for us, so we can see it here. If we had a proper VS Code, we might be able to see it better. But cur data is going to, actually, you know where we might see it? Here. Let's see. Larger than us, 66. No, that's just the line number. Now, there's probably a way we could, I think if, I haven't used GDB in a long time. I do have a video on GDB on Canvas if you want to see it. But there is a command you can type to see the variable contents of data in this case. I don't want to break it though, so we'll keep going. But it's something. It's on the tip of my tongue. We'll come back to that later. Maybe while you guys all think about questions to ask me for the exam, I'll come back and try to play with that. But yeah, all right. So assuming that cur data sees a t in there, it sees that the t is greater than the a that we're trying to insert, and so it went into the if statement. So we're going to insert it now, basically before whatever cur is currently looking at. So cur is the t, and temp is the a. So because the a goes before the t, we're putting the a's next to point to the t. So now we got the a pointing to the t as we should. So now all that remains at that point is just to update the head pointer to point to our new node. Now we only do that if this is the first node of the list, which means that cur is currently set to be equal to the head. That's how we check that. If not, then we don't need to do that. And instead, we need to take the previous pointer of the node before us, which is not the case here. We'll come back to that in a second, and then link it. So if everything goes okay, it should go into the if statement and set head to be the temp. As you can see, it goes in there, it sets it, and it's good to go. Now, I already see a problem here. When we finish inserting it, we should be getting out. This is probably why it's stuck in an infinite loop, because I just inserted what I wanted to, but now it's going to go to cur next and going to try to keep going, and it's probably going to try to keep inserting. If we add more things in here, it would like insert it before every single one of them and just be a mess. So yeah, I mean, it didn't break it right now, but that is a problem. So I'm going to stop this program and make sure that after we do this insertion, whether it be here or here, we need to return out of this. Okay? All right, let's run it. See if maybe that fixes the infinite loop or if there's something else to worry about. Ooh, all right, we're getting output. We're still in an infinite loop, but we're getting output now. So this is probably now more of an issue with a null not being stored. So, but we're making progress. So we know that all the way to the A, we're going to be okay. So let's move the breakpoint there and run it. And as you can see, sometimes you all send me emails like asking me, like, yo, my code doesn't work. What's wrong with it? And I'm like, I don't know. Run it on debugger. And that's literally what I'm doing because I don't know what's wrong with this code. I am as lost as you are until I see what this happens. So it's just the name of the game to get to practice using debuggers. All right, so now it goes into the A. So this time, let's see if it goes into where we expect. So cur data, temp next, head temp, and then see the return. It does see the return and gets out. Okay, that all seems to be okay now. Very good. Let's try to put the C. So the C is going to test inserting at the end of an existing list. So we've done all these steps separately, but we've combined them now into this one function. So that's what we're basically testing because we know something got combined wrong. All right, so we enter the function. We create the node. The node is next pointer is being set to null, so we don't need to worry about that. Head should not be null. It's not null. Very good. Okay. We set up current previous. Sure. Now we're going to loop through. So we have A and T currently there. So cur is currently pointing to the A. So we need to, loop should run one time to then go to the T and then run one more time to get to the null. Let's see if that's what we kind of expect to happen, but let's see what happens because obviously something is not working. All right. So let's go ahead and step into. All right, so it's checking it. So right now it should be checking. Again, we don't have a nice way here to see this, but on VS Code you can to see the content of A and T, or sorry, temp data and cur data. But this should be comparing A and T. This should be saying if A, oh actually Z, because if A is greater than Z, go in the if statement. It shouldn't go in the if statement. It does not. Very good. Now it moves on to the next pointer. Cur next, and it should also update previous as well, as long as cur is not looking at a null. As it did. Very good. All right, the second iteration, we are looking not at the A and Z, but the T and the Z. So it should still skip the if statement. It did. Now cur next, that's going to be looking at null. So cur should be null, and you can see that up here. It got set to 0 right now. If you're well, we're watching live, but if you're watching YouTube, you can rewind and you can see that this had something before it. That's what I expected. And now because cur is equal to null, then it should not run this previous cur update. That way, previous is actually keeping what, okay. I'm just thinking here that maybe it's, so when cur goes to cur next, that's a null. I'm thinking that maybe I should have put this line of code above this here, and that's what's causing issues. Because right now, previous is pointing to the first item, and I wanted to point to the second item. So what I should have done is I should have put this line of code before this line of code. And I don't even need the if statement at that point either. So I should be saying prev gets cur right there. And then I don't need this at all. And if I do that, append at the end of the list. Yeah, okay. Yeah, so okay, let's try that. Maybe that's the fix. There we go. Is that all the things that we have? We have an A, we have a G, we have a T, we have a Z. We don't have a K, so we fixed the infinite loop, but I think we're still missing something because this K is not being inserted. Oh, it's because it's inserting into list 1. That's right. So let's print out list 1 and see what's in list 1. So I'll run it on list 1 and see if K is there. Yeah, K is in list 1. So yeah, it's fixed now. There we go. I like that. I like the thing with that. That's a good one. All right, so let me explain to you why that was happening. So we want, in fact, let's look at how we were doing it before. So the insert, let's see which one we had previous on. Did we have anyone here? We had insert empty, insert beginning, insert end, insert sort. So we hadn't used previous before. That's probably why, because we kind of added it here. So let me explain again as to what this is doing. So we know this is looping. In fact, probably easier to show it to you here. So we know that this is what we're looking at. We have a linked list. And we have cur, which starts out by pointing to whatever head is pointing to, which is just the first item. That's what we say cur gets head. And we also set previous to point to the same thing. So everything's pointing to the same thing. And then every time the loop runs, we make this go 1, 1 until it hits null. And at the end of the loop, cur is literally holding null, which is useless to us. Because that's useless to us, we want to keep previous, or prev, I call it, pointing to the one before the current. So like next update, this goes there, and then this goes there. And then the next update, in fact, maybe I can do them all together. It goes like that. Okay? So that was the intended behavior. Now, what the actual behavior was that we had an if statement, which I throw in because I was trying to fix something else when it's like you're patching a bug, but not fixing the bug, which can work most of the times, but not this case. We were updating previous with the current, but we were doing that after updating the pointer. So what that was causing was skipping it by 2. So current and previous were basically pointing to the same thing all times. So like they were basically paired together. So you were going like this. So at the end they were both either null or like because we had that if statement, then this was like here. It was a mess. What we should have done is say copy the current value of prev. So for just that one line of code, have prev and current point to the same thing, and then update cur. Or I guess you see it this way. So only update it after you copy it. So mechanically, like if I go this like step by step, I'm saying, okay, let's get rid of this. And let's just say there's other things before this. I'm in a situation where I have this to the one before it, and this is the next one. So I say, okay, go ahead and say prev gets cur for this line. So we put it at the same, and only have to do that. The line next to it says cur gets cur next, which then is going to move this like that. And so we'll be back to what we want, which is the P pointing to the node before the last one. Why do we do all of this? So that we can actually, at the end of the list, append something. Because at the end of the list, the next time you update this, if you think about it, P is going to go here. And when it does that, we just draw a smaller one. When it does that, and C does C next, that's going to go to null. But that's okay, because we still have access to P. So if we want to link this pointer, we know that P next is this right here. So I can just append my node there by saying P next gets temp, which is the equivalent of basically saying, here's a new node, make that point to it. And it doesn't matter that cur's pointing to null because that's okay. We're done inserting, so like forget about that. Okay, and this of course is already null because of the constructor. So yeah. All right, so we fixed it. I'm glad. It only took us 20 minutes. All right, but that does show you some good practice of using a debugger. All right, so that's how you insert, and now we've created a sorted list. We can, of course, grow this as much as we want. Let's try duplicates. Let's see if it breaks with duplicates. We might need to add an equal sign somewhere. We'll see. No, it doesn't break with duplicates. Very nice. So it still got the A's and everything. Let's try duplicates at the end of the list. That's another possibility of breaking it, I presume. And then maybe a duplicate in the middle, like a G. So A, G, G's, GG's, and then Z. All right. Yeah. So it's good to go. Okay, so that shows you, again, the hardest part of a linked list is inserting. But let's do a delete. I think a delete would be useful. So let's do a delete at. Or, well, delete at is nice, but a really fancy one would be like delete and then give it a letter so that it scans for the letter, finds the letter, deletes the letter. That's harder too because it does need to not just locate the letter, but delete it. And there's a lot of cases for deletion, right? So let's look at that. Deletion is basically the opposite of insertion, but also from like an implementation perspective. So remember there are 4 cases for insertion that we talked about. When thing is empty, you insert something. When something exists in the list and you insert at the beginning, at the middle, or at the end. So those are 4 cases. For deletion, it's kind of the same thing when you think about it. So delete or deletion. Okay, so we have the special case that we want to keep always at the top, which is delete the last item from a list. So basically we go from a list with 1 item to a list with 0 items. Why is this special? For a simple reason. It's not particularly hard actually, it's just because of that one reason. And that is, if the list is now empty, we want to fix what we had issues with earlier, is that we always want head to be equal to null whenever the list is empty to avoid the whole headache we had earlier. So that's what's just the one thing you got to make sure you keep track of that special case. The other 3 cases are when, and I guess technically speaking, there's a 5th case, which is like trying to delete from an empty list. You should give out an error and say like list is already empty. You can just check if null is if head is equal to null already. So I guess there's that 5th special case, but yeah, that's not really much thought about that. Just add an if statement and be done. Okay. All right, now it's getting a little weird with the emote. Okay. Uh, so the other 3 deletions are delete at start, delete at end, and like middle, basically. So let's just kind of draw some pictures for that. So if we want to, let's label these with numbers. So we'll call this like, we'll call this examples 0, 1, 2, and 3. So if we want to delete at the end, that's like deleting 3. This is 1, and this is 2. And of course, if we only had one item in the list, and we call delete on that, that would be example 0. Okay? So those are the 4 cases. And again, there's that 1/5, which is like if there's nothing on the list and you call delete, just make sure you don't program this in like segfault or something. Or just don't let people call it that way. So what we're going to do is say like delete a letter, and this thing will find if the letter exists. If it is, delete it. We could also make it delete all instances of a letter, so like delete duplicates too. So yeah, and I think that's going to be because we already know how to print it. So that'll pretty much wrap up. If you know how to do insert and delete, you're in business for this. And of course, you want to make sure you have not. I mean, linked list is not in the second test, but make sure you have all these kind of things down by the final. Write them down or print them out, or well, no, don't print them out. That's weird. But like copy them somewhere so that if somebody asks how to do a function like this, you don't have to reinvent the wheel. You have like the answer. You just have to modify it. They might ask you to do numbers or template it. In fact, I think the final project is templated linked list. So yeah. Okay. So let's go ahead and add delete then. Let's see if delete doesn't turn out as buggy as insert. All right. So let's add the prototype here. So we're gonna call it. I'm gonna make it fancy. I'm gonna make it not just delete something. I'm gonna make it return how many items it deleted, just because it's useful. Oh yeah, good point. So I'm not able to update that since I'm not in my house. But what I've been doing so far is I've been posting the codes on Discord. So if you have access to Discord, let me know. Otherwise, I'll probably maybe make a separate file for these and send it. Uh, but I will update it on Friday this week. But yeah, I've been posting them on Discord. Assignment is already templated linked list. Yeah. Well, hey, I asked you. I said, you guys want me to do a templated linked list or a non-templated? And you all said like, don't make it templated. And this is before either of us knew that the assignment was templated. So you could have had a templated linked list done in class, but you said no. So just bad luck, I guess. All right. So delete at, or no, delete, just delete. We'll call it delete and pass whatever we want to delete. But yes, I will update the file. In the meantime, just check out Discord. It is there. They've been there. Like for example, this broken code was there, and now we'll now post the fixed version because we fixed it today. All right, so we got a delete function. It's not void, it's int. And the idea is that it will find, it's like search and destroy kind of thing. It'll find whatever letter we pass in and delete all instances of it. And it'll count how many instances it deletes. So like if we say delete on like on the Z, it'll delete all 3 of them and it'll return to me the number 3, meaning it deleted 3 of them. That actually will be a good test for it to call it on Z. Um, oh yeah, good point. That's probably delete. Yeah. So let's call it, well, I guess you could call it search and destroy. S and D. Yeah, reserve keywords. Python lets you do whatever you want. But no, C++ will be like, no, no, delete is the allocation. Don't use that. I hope S and D will be something else now. But, all right. Let's, I know we haven't finished it, but let's just write it here. So we'll do like a before and after so we can see it. So it's on list 2. So we'll have list 2. Here we can comment this print statement out. And then we can comment. Oh yes, yeah, that I know. Well, that's what I was thinking when I the yeah, the Call of Duty mode, yeah. List2 dot snd z. That's how we'll test it. We'll see if it actually deletes a z. And maybe we also want to test it with a letter that doesn't exist. So W. And then maybe we'll delete the A's from it too. Yeah, because those are at the beginning. That'll be a good test case for the A's. And finally, we're basically killing everything. We'll delete oh, the G's gonna leave it empty. Let's leave the T first. And then let's print it out. And then we'll test one more case, which will be deleting all the G's. So yeah, we got all the test cases set up. Then we actually got to code the thing. Although this if we run it, it'll run right now because it'll just do nothing. So yeah, let's just run it. Make sure everything compiles. Uh, no return statement. Oh yeah, yeah, I know that. Okay. Also, let's uh, let's see out the value of this. Since remember, this is gonna see out how many instances of that letter it deleted. And you know what? Let's go hardcore. Let's go recursive. I don't know. Should we? I mean, on one side it's good because I show you recursion. On the other side, it's gonna make it a little more complicated. Not a lot, but a little bit. Maybe we'll do iterative. Get because I want to get that example clean so you can use it in your assignments and tests. And then if we have time, we'll do a recursive version of it. It'll just be a lot of copy pasting and we'll be done quickly. So yeah. All right. Cool. So now for now, I'm just gonna make it return like return one, just to see that everything is running smooth. Oh, so yeah, I found out I should add a line feed. Or actually, here. Okay, let's try it again. Oh, why did I use single quotes? Did it die on me? Died on me. That's one more instance of GDB. Go away. Oh, no. Oh, it did finish running. Oh well. Should send it to another one. I mean that's gonna be okay. That'll be okay. All right. So okay, so everything is ready now. So we just gotta code the actual delete function. All right. So the way we're gonna do this is kind of very much like the insert. We're gonna take the same concept of the insert of using a loop and keeping our current and previous, and just basically iterating until we find what we want to delete. And after we delete it, instead of quitting the function, just keep going until you hit null. That way you delete all instances. You just keep a count. So, start out by making a count variable and then return that count. So that'll take care of that as long as we increase it. And of course, before, we're going to have our 2 pointers. So we're just going to copy and paste them. We also want to have this whole if part. So here, let's just copy and paste. Let's actually just copy and paste the entire function and go from there. So the only difference is we don't want to allocate a function or a node. And then when we do see a null for the head, that means the list is currently empty. That means we can't delete anything, right? So that's, we can say like list is empty, can't delete. So that's the first if statement. Oops, sorry. That's the first if statement we have. And in that case, we could put a return statement right here and not put this in an if else clause, but I'm just going to do it kind of nicely and not do that. And this will return count, which should be 0 at that point. Okay. You don't have to put that. You don't have to put the cout statement in there, but I'm just putting it for why not. Okay. But you can see it's the same checks. We still have our pointers. We are going to use those. Uh, we are going to be using this. We no longer need this as well. And so now we have our if statement as before. But this time, we're not comparing temp data because that doesn't exist. What we're comparing is the car C that's here. And you want to find out not if it's less than or equal to, but sorry, not less than or greater than, but we want to see if it's equal to, because that's when we're going to delete it, right? When it's an exact match. So we're going to compare car data with the C, and if it does match, then that is a match for what we want to delete. So we have a match of something to remove. Okay? Removing it is going to be tricky though, because we have to make sure we don't break the linked list. That's going to be the hardest part. If we just, like the actual removal process is like delete cur, and you're done. But now you have memory leaks and not memory leaks. Well, no, you do have memory leaks technically, but more than that, you have no. You kind of have memory leak, but you have a dangling pointer, which is worse in this case. If you want to have real memory leaks, then you can just say cur gets null or something. So anyways, the point is that it's not as easy as that. We have to take, and this is where we're going to go back to the drawing board. If let's say that we're deleting the first one. If we're deleting the first one, it's a little bit easier because all we got to do is basically just like deallocate that. But head, if that's the first item of the list, is pointing there. We need to update head to now point there. So that's what it takes for the first one. For deleting something at the end, yes, we can deallocate that. But to avoid dangling pointers, we need to severe this link right here by setting this to null. Right? So that's going to be that step. So we got to set that pointer to null, and then we're good to go. For the middle one, if we want to delete this one, we need to update this pointer to point there. And then that's it. Then we can just like, throw this away and everything. How to update that pointer is going to be something like cur next is equal to like cur. I don't know. It's going to be probably prep, not cur next. Next. It's going to be some weird line like that. Okay. But yeah, those are all the cases that we got to think about. We got to be careful about. So the point is that we know if we hit this line that cur contains what we want to delete. Cur. That's the node. So if we were trying to do now is delete the one before it, I'm sorry, if we're trying to link it with the one before it, that's the one where it's in the middle, or if there's nothing before it, then we just gotta update head, or if it's at the end, we just gotta change the pointer. So we gotta basically make a bunch of if statements for that. So let's start out by checking whether we are at the beginning of the list. How do we know that? Well, let's see if head is pointing there. I know I have it written like this, but I'm gonna flip it around because I feel like it's more intuitive if you see it this way. If head is equal to cur. Because what that's saying is that head is literally pointing to cur. So if we are deleting the first node of an existing list, that's what we're looking at. If that's the case, then we gotta update head to point to the second item. So update head to point to second node if it exists. Because it might not exist. It might be like a single node thing. That's the one case, right? So we know that the first node exists. We don't know that the second one exists. Turns out that it's not as big of an issue. Because here's the thing. If cur is the only node in the list, cur next is going to point to null. So in that case, head is going to point to null afterwards. That's good for us because that means we know that null equals empty. If it's not empty, then it's going to be a valid node and it's just going to point there. So it turns out that we can actually achieve both cases here with that line of code. All right, so that takes care of that scenario. We have now the else clause. The else clause is going to be if the node we are deleting is not the head. If it's not the head, it could be one of two things. It could be at the end or it could be in the middle. Do we have to worry about both cases as separate or not? Turns out that we don't really need to worry too much about both cases as being separate. But you have to be a little careful though still. Because here's the thing. If it's the end here we're deleting, we just got to make sure that we set this pointer to null. If it's in the middle, we got to link it. And when we're linking it, we're accessing cur next. And if this is already null, then this might be a null pointer dereference and we might crash. So we got to just add some extra checks for null to avoid any bad issues. Okay? So if the node that we're not deleting, if the node we're deleting is not the head, this is going to stay the same. And let's just get rid of that line because it's weird. We don't need that right now. Okay? So if the node we are deleting is not the head, what are we going to do? Okay? We can check if it's at the end. So like if cur next is equal to null, PTR, then that we know that this is the last node that we are deleting, right? If it's not equal to null PTR, then this node is in the middle. So now we have our two cases. We may not need both cases, we might combine them, but I'm just listing them out in case you needed to do something else on your assignment. All right, if the node we're deleting is the last one, then all we got to do again is just deallocate it and set the previous one to null. So set the previous next to null, which is the last node's next pointer, and then just delete cur. Okay? Oh, that's a good point. I forgot to delete it up here. Well, I can probably combine all the deletes together. That way I just put them down here instead of the return statement. Like that. Yeah, that way I don't have to put it 45,000 times. At some point I got to deallocate the memory, so just make sure we do that. So. All right. So previous next null is going to sever the link to the last node and make this previous node the last node now. So that'll take care of that. And for the middle, all we got to do is that link that hops over. So we want to say prev next. That's the one we want to update. So we're going to say prev next is going to get prev next. That's one way to do this line of code. The alternative way to do this, so only do one of these, is to say prev next gets cur next. This is a little trippy, but these two lines are equal. All right? In fact, we can test it with both, but I'm going to comment one of them out. There's no need to have both. Let me draw you the picture of why that's the case. So if I have, and here's my head, here's my P, here's my C, prev and cur. Okay? So I am trying to delete cur. So this is the node that I'm trying to delete. I want to link this. I want to link this here. I want to make that link. So I want to get rid of the current link. I want to get rid of this. And I want to replace it by this. So if you think about it, Pn is the name of this. So Pn is right now currently equal to C. And if I do Pn n, because Pn is equal to C, that's the same thing as saying Cn, right? So this is the same thing as this. So what I want to do is I want to update Pn. I want to make that equal to, because that's this arrow. I want to make that point there. Where's that at? Well, that's what Cn is pointing to, right? That's this arrow. So I could say previous next gets curnext, but I can also, since I know that Pn is equal to C, I know Pn is equal to C, right? Well, then I can just replace C with Pn. And that's how I'm getting this Pn and Pn right here. Okay? So if that's a little weird for you, then just practice more and play with it until it makes sense. Experiment. So that's how I got this line of code. That's probably the hardest line of code in the linked list. All right. Once I do that, I cut off the link to the cur. So now I got to delete kernel instances. This is for, once I finish deleting this instance, I want to update the pointers. The only issue here that I see is that if we delete something, this is technically a dangling pointer. But it should work either way. I'm going to fix that, but let's just test it. I want to see what happens. Count gets, oh, int. All right. Well, I don't think it's fully working, but it's partially working, and it didn't crash at least. So let's fix this though. Let's fix this. Let's fix the dangling pointer issue I'm talking about. So the issue I'm talking about is that technically speaking, I am deleting cur, but then I'm dereferencing it here twice. So if you want to be a good citizen per se, then you want this to happen after you do this line of code. So, well, there's a lot of ways I can do that. What's the nicest way that I can do it? I can make a temporary pointer. Or I can just reset the loop and not have to worry about it. It's not efficient, but it'll work. Yep, that'll work. It's going to reset the list, and then I won't have to worry about anything else. Alternatively, what I could have done is I created another node pointer called temp, copy the value of cur to that, and then make sure that I reset prev. Otherwise, weird bugs will happen. So, yeah, that's probably also going to fix the other issues that I had. Yep, it did as well. So, yeah, two birds with one stone, basically. So, always watch your dangling pointers. So, yeah, let's make sure this worked. So, we have that. And first we do is we try to delete. Oh, well, oh, shoot. One more thing we got to fix is the count. Right now, we left it at 0. So, every time that I call the delete, where's that at? Here, I want to increase my count by 1. Right? So, I want to make sure that the count works. It's also good for debugging. All right, so let's see. It deleted 3 Z's. Yes, that's good. It deleted 0 W's. That's good because there are no W's. It deleted 2 A's. Oh, that's not good. It should have deleted 3 A's. Oh, we have a bug. And then it deleted 1 T. So we should have ended up with GG, but we have this A. So what broke in the A? Let's try to put a breakpoint and then run the debugger. It's probably the case of deleting the first item. Probably something's messed up there. All right, so let's step into that and see where it goes away from what we kind of expect. So can is 0, sure. Head is null. Head is not null right now because we have 3 A's. Well, actually, what does the list look like before the A's? So we have this. We deleted the Z, so we have AAAGGT. It ran the W, didn't delete anything, and so now we have, yeah, so we have basically that. That's what we have currently on the list when this is running. Obviously, head is not null, so it should not go into that. It goes into the else, prepares everything. All right, jumps in. Well, cur is not null. The first letter that we're looking at is an A, so it should delete it. It goes in, very good. Is head currently what we're trying to delete? Yes, it is. Okay, head gets updated to the next item in the list, as it should. And it calls delete on that, increases the count, resets the head, and goes on. Ah, that's okay. That is probably the issue. After we reset the head, we want to go back to the top of the loop. We don't want to run this piece of code. We only want to run this if nothing was deleted. So I really should put this in an else clause. Let's do that. Because I want to basically start from scratch after I delete a letter. So otherwise, um, I skipped the first letter, which is why we're getting an X-ray. That totally makes sense. Okay, this might break something else in the process, but no, it fixed it. Okay, yeah. So what was happening from like a drawing perspective was this. So when the code ran, here, let's just keep. I'm drawing like 40 linked lists today already. There we go. So when the code runs, as before I had it, before the fix, what was happening is we see that the head is equal to what we want. You know, head data contains what we want, which is that C character, or well, it's an A, but it's car C. That's the identifier. So we do the deletion and everything, and at the end of that, we reset cur and prep to all point to the head as you start the code with. Everything is good there. But then we increment cur to point to the second thing. And prep is stuck in the first one, which is kind of okay. But then we are looking next at this letter. So we never looked at the first one, if that makes sense. Let's do it slower, actually. So I think I explained that very well. So we have A, and then G and other stuff. So we start out. Here's our head, and we have C and P, and R and P pointing there. We see that it's the same, so we deallocate it. So, bam, that gets nuked basically. Then we update head to the second thing, so that gets pointing there. And then we update both C and P to the new head, which is that. Now we're ready to go again. But I had the prep get cur here, which we need to be able to, if in the case that the letter we're looking for is not what we want, we need to be able to advance. So I had that always happen. But when we delete something, you actually want to check the thing that you're not pointing to instead of increasing this by 1, which is what that line does. So of course, when we did that, now we were basically checking this A, and we basically ignore that one. So that caused the issue. So basically the fix is that you don't update this whenever you do delete something. You only update it when you don't delete something. You do want to update it, otherwise you're going to iterate forever. So yeah, okay? So there you go. There's your delete function, and like I said, I will be posting this on Discord, and then on Friday I'll post it on Canvas once I get back. So I'm probably have to split it into 3 files because Discord's file limit. But yeah, in fact, I'm going to do that right now because that is the end of the lecture, and now we open the floor up to questions on the test or anything you want me to review. So feel free to go ahead and post that while I go ahead and post on Discord the. Oh, by the way, there's a share button here. Oh, cool. Share code. Here. Try that out. I think that actually shares the code. It's kind of like ID1. Oh yeah, this is way too big. Desktop ls linked list example .cpp. I'll look at the chat in a minute. Feel free to throw in all your questions for the exam and whatnot. That way it's one massive file. Yeah, there we go. And it's still color coded. All right, that worked. So it's been posted. And by the way, I have examples of linked list already coded that I coded past semesters on Canvas. So you can check those out as well. Yes, there is an extra credit opportunity to turn in your notes, but they have to be good. It's not just any notes. Uh, are you talking about which extra credit? The augmented reality? If so, that one's gonna take us like 2 weeks to get done, so you won't see that anytime soon. But you'll see it sometime. Like what I'll do is I'll post an announcement and be like, okay, everybody's extra credit's been posted for that. So then check it. That way, if you find that you didn't get it, then you can see and then we can investigate. Oh, you did ask the app one. I don't know. I didn't read that like a second ago. That was weird. But yeah, that'll take about 2 weeks. Probably post Thanksgiving, you'll see it. So we gotta go through each of those and match them. So, well, I'm glad the link worked. I wish I'd known that last time. I could have shared it too. But yeah, there you go. I like this. I like online GDB more than ID1. I might start using that once new in person. There's also this beautify button. I wonder if it'll actually make it look good or it'll break it. Ugh. Oh, it made weird tabulations. I'm glad I saved it. I don't like those. Oh, it like lined up the. Oh, that's horrifying. Okay, the beautify did not work very well. That's weird. Very sad. Sad beautify. The MySQL has a really nice beautifier for SQL code. Yeah, the beautify is definitely not the not the meta. I like my version better. But yeah. All right. What are your expectations in terms of notes to turn in? Well, look at the ones that are already posted from past semesters. One expectation is that it'll be shared with others. That's like an actual expectation that you should be aware of. Um, VS Code does have some really nice beautified options, I think. So, but still, MySQL is the best one for beautifying, where it actually does a good job. Beautifying for code is really dependent on the person too. You have to set it to your own settings to what you think it's, beauty's in the eye of the beholder kind of thing. But yeah, for the notes, just you have to make the notes be good enough for others to use as a study guide in future semesters. And yeah, and yeah, I mean, any test questions? I mean, the time is ticking. This is your chance to ask if you would like to clarify something. I'm gonna go and look at the. Oh, let me hide that. There we go, hidden. I'm gonna look at some of the test questions and see if there's anything in particular that stands out to me. that I can talk about, but I doubt, what I think is hard and easy is not what you think is hard and easy. So, and that's just not because I know more or less. It's just each person finds things different. Like operator overloading, I'm not a fan of that. Not a fan at all. But templates I like. Other people might be the other way around. They might like templates, but they love operator overloading. Recursion. Yeah, a lot of people don't like recursion. I use it for what it has to be used for and not for other things. I don't make things recursive unless they have to. All right, I found the test. No, wait, this is not. This is 2020. Okay, I think this is it. Preview. All right, so it looks to me like, assuming this is actually the test, which I believe it should be, because it says fall 2021. Seems to be like it's a question pool, so everybody gets different questions. So if you get a question and you have a question for us, make sure you give us the code of the question because all the question orderings will be like madness and different. It seems to me that you have the first question, where you got to read the instructions and blah blah blah. So really, you have about 20. I think it's 21 or 22. I don't know if I'm doing the math right. I think 21 question test. There are 21 question tests. We'll do the same time stuff we did for the first one, and there's final exam two, right? Yes. So Wednesday, this Wednesday you have exam two, and then you have your final on study week. Not sorry, not study week. The week after that. So that was the week of December 6 to 10, and the time of the test is going to be announced at a later time. I actually, if you go to my UNLV under my final exam schedule, it'll tell you the time. I actually don't know what time the test will be. If I was to guess, it's probably going to be on a Monday or on a Wednesday from 6 to 8 p.m. or like 4 to 6 p.m. But probably 6 to 8. What you want to do is you want to just see there. That it'll show it there. And the reason why we use that time is because like it's a 2-hour block of time and it gets coordinated so it doesn't conflict with your other finals basically. So, yeah, we'll talk more about that later on. But yeah, so yep, hopefully you have enough time. Well, I mean, silver lining is everybody gets the same amount of time and everybody gets the same test. So, we've already bombed it and it'll be curved. So, yeah. There shouldn't be a test on the 24th, right? 24th of November? I don't know. What is it? I mean, no, because there's a test on Wednesday, but the 24th is like just a random day. So, yeah. The others use KNR style, which is great because I prefer brackets to be on the same line as functions, loops, and conditions. Uh, I like KNR because I don't like brackets being their own line because it's like when you're writing a lot of code, it just becomes unnecessarily like vertical. For teaching too, like for teaching, like I like I like to fit more the most I can on the screen. So like, look at this piece of code. One bracket, two brackets, three brackets, technically four if I put a bracket for this single if statement line. So like that's 5 lines of code if you that we're basically cutting off all of this code, right? So you end up with less code on the screen. So for teaching, I like code to be as compressed as possible. And also that kind of segues into my own coding. I like to write compressed code. Like I'll be the one who does this. I prefer that too. So, but I mean, you do what do whatever you want. Just make sure you are consistent. Nobody likes the person that does code like uh, what I did here, which is like this is a single line of code with curly braces and this with nothing, right? That's what people don't like, and I agree. Also, you want to use the format that the code base uses. So if I'm stuck with a code base where they actually are using what you're saying, then I'll stick to it. You don't want to change the random indentation style like in the middle of like the code just because like this is me, I am the one who coded this, I'm putting it in my format in the middle of like a completely different format. That's just like toxic. Yeah, 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 yeah. Each line for each bracket is just no way. All right, hiding this again so I can go back to looking at the test. So I'm not gonna tell you test questions, but I'm gonna, you know, wait, this does not feel right. Oh no, this is related. Okay, this question's asking about binary operators, but yeah, no, we talked about that with operator overloading. It's just like for a second I was thinking like binary, like it's just like basic math, but no, no, no. All right, so you got some things where you got to like overload a class. You're giving a class, and you're like overload this so you can use this multiplication, like be able to multiply two values together. So fair enough. If you get any of the, did we, I think we covered exception handling in the videos that I made you watch. But either way, the same logic applies as the first test. If you get a question on a topic that was not covered, just let us know, and you get the free points. You get the RNG gods on your favor. Here's a question that's asking you to describe what something is. And that something is one of the concepts that we learn. Like, it's not the one that it's asking, but like imagine it was asking you to describe what operator overloading was. It's asking you to compare things. So like not all of these are code questions. They're concepts. Some of them do have code. They ask like, given this code, write this code. Like I said earlier with the operator overloading. But consider the following code. There's a function right there. It's templated. Is this function guaranteed to work? Ah, okay. Yeah, so you get a templated function, is it guaranteed to work? Why or why not? Remember, a templated function can accept literally anything you want. And if you got built-in operators in there like a plus sign, it'll work with strings, it'll work with classes, but only if you overload operators for it, right? Oh, recursion. Let's see, recursion. Consider the following recursive function. What is the output? Ah, it's easy. Well, yeah, that one's relatively straightforward. Write a recursive function to do something. And then you get some examples of how to run it, like expected output kind of thing. And at the end of the test, you get an additional extra sheet. Oh, I like this. Oh, this is nice. So, okay, this says this can be used as an additional sheet like your hard copy sheet. If you think of any questions or options are incorrect, then you can use this question and include your assumptions. Oh, I like this. Okay, so let me actually hide the rest of the test and share this. So I guess that, I'm happy that Sam and Kishore added this. So now, if you find a problem with your test or you make an assumption like, oh, there's a missing piece of code on this, I'm going to assume that it's this, you can write it in on the last question of the test, write the question number in there, not the number, but the actual code of the question, and then mention it. So even if we can't get back to you, like even if like you don't get a response from us, which I'll be here and the TAs, I told them to be active, but like even if you don't hear back from us, you can write that in the test itself. Any assumptions you make, any mistakes you think the test has, and any questions you don't know the answer to because we didn't cover it. Just throw all that in there, and anything else you want, you can throw in there. And it says 0 point question. So actually, you have probably like 19 questions that are real because there's this. See, this counts as a question. So it says 23, but then like the first question is just the the cover of the test, and I think there's two of those. So I think you might have 19 total then. But so yeah, hide that before you see the test by accident. So yeah, 22 is a legit question, and then two is a legit question. So like 20 questions basically. Polymorphism. Remember that term. Remember, virtuals are going to be on the test. That's probably the thing we've spent the longest here for. So you make sure that you remember how to do virtual functions in C++. Okay, so that's it. I mean, I was expecting more questions from you guys in terms of like, oh, can you remind me how to do this or that? But nobody asked questions, so I try to at least give you some overview. So then that's it. Unless anybody has any last minute questions, we got 3 minutes left. Well, you can always send me a message on Discord or email or post a public chat on Discord. Oh, by the way, make sure same rules as last time. You have to do radio silence for the. I think since we're on. See, I don't. I I think see you, you get lucky here, or well, for the first test you had to take it first. For the second test, you take it almost last because I think the test is being given on a Tuesday Wednesday basis because Thursday's Veterans Day. So you're probably one of the last groups to take the test. Still keep radio silence until the end of Wednesday, and then you can talk about the test. In the public chat, I'm talking about, of course. You can talk about the test with me at any time. So, yeah, having said that, since I won't see you on Wednesday and I'll see you until next Monday, I am wishing you the best of luck with the test. And, do good on the test. But more importantly, just do your best, and I'm sure you'll be fine. Get some good rest before the test and code a little practice coding, a little bit of recursion and virtuals. I think like that. I'm just thinking virtuals has been such a long time. I feel like you're gonna be rusty on that. So yes, do good on the test. Make me proud, and then we'll see each other on a week from now. And yeah, anything, just hit me up. Last reminder: if any of you have a DRC accommodation where you get extra time or some special scenario, you gotta tell me by the end of today so that I add it in on Canvas. I only got from both. 302 is also taking tests, so there will be no class on Wednesday. So I've only gotten one person, but I know that there's a couple of more. So please, if you have something like that, just message me. I have to add it, but I can't if I don't know who it is. Can you keep the stream up for another minute? Well, class ends in a minute, so there you go. You should be saving your points for the extra credit. The DAB doesn't get your points. All right. You are welcome to start redeeming the extra credit, the big extra credit point thing, if you want. And if you do, just send me a. Well, yeah, but I'm gonna make smaller subsets of that. So, like, starting probably not maybe by Thanksgiving week or the week after, I'm gonna make like smaller increments so you can use your points. So you're not gonna get to 20,000 points now. So you can get like a 5,000 tier. We'll make smaller tiers. I don't release those before because then people redeem those and I get like 50 of those. I don't want people to redeem like a 50 pointer or something like 20,000 times. So yeah, hashtag scammed, I guess. All right. Good luck, everyone. And I'll see you next week. Take care. Bye. Have a good weekend, everyone. Or not good weekend. Have a good week since I don't see you again.